Assalamualaikum and good day everybody. Welcome to Belajau Melaka with Cikgu Siti Zubaida from SMK Bukit Baru. In this lesson, we are going to learn gravitation with the topic Newton's Universal Law of Gravitation. There are various types of man-made satellites revolving in their respective orbits in outer space. Satellites are invented for communication purposes, weather forecast, and Earth observations. Why are these satellites able to revolve in their respective orbits? In 1667, the scientist Isaac Newton observed an apple which fell vertically to the ground and the movement of the moon around the earth. He subsequently concluded that a force of attraction not only exists between the earth and the apple, but also between the earth and the moon. There are many situations showing the existence of force between an object and the earth. For example, a person who jumps up will return to the ground. Or the moon revolves around the earth without drifting away from its orbit. Or air molecules remain in the atmosphere without escaping to outer space. So, what is gravitational force? Gravitational force is universal force that acts between the two bodies in the universe. For example, a gravitational force exists between the sun and the earth, also exists between the earth and the moon, and also exists between the sun and the moon. In the year 1687, Isaac Newton presented two relationships that involve gravitational force between two bodies. Let me explain the first relationship. Let's say we have body 1 with mass m1 and body 2 with mass m2. They have gravitational force between each other, and they are separated apart with the distance r. So, the first relationship states that gravitational force is directly proportional to the product of masses of the two bodies. So, F is directly proportional to m1 times m2. Now, look at body 1 with mass m1 and body 2 with mass m2. They have gravitational force with each other with the distance r. The second relationship states that gravitational force is inversely proportional to the square of the distance between the centers of the two bodies. So this is the relationship. F is inversely proportional to r squared. So these two relationships, when we combine into one, it will become F is directly proportional to m1 times m2 divided by r squared. The formula will become F equal to G m1 m2 divided by r squared, where F is the gravitational force between two bodies, m1 is the mass of first body, m2 is the mass of second body, and r squared is the distance between the center of the first body and the center of the second body. Don't forget the value of G, where G is the gravitational constant, which is 6.67 times 10 power of negative 11. Example 1. Calculate the gravitational force between a durian and the earth. Mass of durian is 2 kg. Mass of the earth 5.97 times 10 power of 24 kg. Distance between the center of the durian and the center of the earth is 6.37 times 10 power of 6 meter. The first step, list the given information in symbols. M1 equal to 2 kilogram, M2 equal to 5.97 times 10 power of 24 kilogram, R equal to 6.37 times 10 power of 6 meter, and G equal to 6.67 times 10 power of negative 11. Step 2. Identify and write down the formula used. The formula that we are going to use is F equal to G M1 M2 divided by R square because we need to find the gravitational force. Step 3. Substitute numerical values into the formula and perform the calculations. Then, substitute the formula. G equal to 6.67 times 10 power of negative 11. M1 equal to 2. M2 equal to 5.97 times 10 power of 24. And R equal to 6.37 times 10 power of 6 square. Then, use your calculator to calculate. The final answer will be 19.63 Newton. Gravitational force acts between any two bodies, including those on Earth, planets, the Moon, or the Sun. What are the effects of mass and distance between two bodies on gravitational force? Imagine you and your friend are bodies on Earth. Your mass M1 is recorded as 55 kg and your friend M2 is 65 kg. If the distance between both of you R is 2 meter, so the gravitational force will be equal to G M1 M2 divided by R squared. Substitute the formula where G equal to 6.67 times 10 power of negative 11, M1 55 kg, M2 65 kg, and R 2 squared. The answer is 5.96 times 10 power of negative 8 Newton. Let's increase the value of the distance from 2 meter to 4 meter. F equal to G M1 M2 divided by R squared. We substitute the formula. G is 6.67 times 10 power of negative 11. M1 is 55, M2 is 65, and R is 4. The answer is 1.49 times 10 power of negative 8 Newton. Previously, we calculate when R equal to 2, F is 5.96 times 10 power of negative 8. Now, when R is equal to 4, F equal to 1.49 times 10 power of negative 8. We can conclude that when the distance between two bodies between them is increased, the gravitational force is decreased. Hence, more separation distance will result in weaker gravitational forces. Now, let's say you and another friend with different mass stand beside each other. F equal to G M1 times M2 divided by R squared. So, substitute the formula. G is 6.67 times 10 power of negative 11. M1 is 55, but M2 increased to 75 divided by R squared. The answer is 6.88 times 10 power of negative 8 Newton. If the mass is 65 kg, the force will become 5.96 times 10 power of negative 8. And now, when the mass is 75 kg, the force will become 6.88 times 10 power of negative 8 Newton. We can conclude that when the masses is increased, the gravitational force between them will also be increased. Why the gravitational force between you and your friend is small? It is because the mass of you and your friend's body is comparatively really small to the Earth mass. As a conclusion, the larger the mass of the body, the larger the gravitational force. Gravitational force decreases when the distance between the two bodies increase. Let's discuss activity 3.3, page 82. The first one. What is gravitational force on the man-made satellite before it launched? The mass of man-made satellite is 1.2 times 10 power of 3 kilogram, and distance between the Earth and the satellite is 4.22 times 10 power of 7 meter. Force equal to G m1 m2 over r square. The Earth mass is 5.97 times 10 power of 24 kilogram, and the radius of the Earth is 6.37 times 10 power of 6 meter. We substitute the formula where G is 6.67 times 10 power of negative 11, m1 we refer as the mass of the Earth, 5.97 times 10 power of 24 kilogram, and m2 is the mass of man-made satellite, 1.2 times 10 power of 3 kilogram. The radius, we took 6.37 times 10 power of 6 because the man-made satellite is still on the Earth. We use calculator to calculate. The force equal to 11,776.13 Newton. Number 2. Compare the mass of the Earth, mass of the man-made satellite, and the mass of the Sun. The mass of the man-made satellite is 1.20 times 10 power of 3 kilogram. The Earth is 5.97 times 10 power of 24 kilogram, and the Moon is 7.35 times 10 power of 22 kilogram. The Sun mass is 7.35 times 10 power of 22 kilogram. From the value of the mass given, we can say that the mass of the Sun is bigger than the mass of the Earth, and the mass of the Earth is bigger than the mass of the Moon, and the mass of the Moon is bigger than the mass of satellite. Number 3. Compare between the Earth-satellite distance and the Sun-Earth distance. This is the Earth-satellite distance and this is the Sun-Earth distance. We can say the distance between Earth and satellite is smaller than the distance between Earth and Sun. Now, predict the difference in the magnitude of the gravitational force between man-made satellite and the gravitational force between the Sun and the Earth. As we know, the mass of the Sun is bigger than the mass of the Earth, and the mass of the Earth is bigger than the mass of the Moon, and the mass of the Moon is bigger than the mass of satellite. And we also know that distance of Earth and satellite is smaller than distance of Earth and Sun. Now we need to compare the gravitation force between these two situations by using the formula force equal to G times m1 times m2 over r square. So what is your prediction? Which one is bigger, which one is smaller, or the gravitation force are the same? Let's do the calculation. Now calculate the gravitational force between Earth and the satellite and the gravitational force between Earth and the Sun. We use the Newton's universal law of gravitation formula F equal to G times m1 times m2 divided by r square. These are the values of mass and distance between the Earth and the satellite and distance between the Earth and the Sun. We use the formula of Newton's universal law of gravitation, F equal to G m1 m2 divided by r squared for both questions. We substitute the correct numerical values, we will get the gravitational force between Earth and satellite is 202.56 Newton, and the gravitational force between Earth and Sun is 2.12 times 10 power of -5 Newton. Does your answer match your prediction in previous question? Okay, that's all for now, children. We are going to continue to learn Learning Standard 3, 4, and 5 in Part 2 video. Bye. Thank you.